We're doing AC grounding for safety. We're doing RF grounding to prevent RF feedback and also to feedback loops. And then lightning protection, which is to prevent lightning from getting in the shack, or at least try to deal with it if it does get in the shack. AC safety, the basic concept, of course, is protection from loose wires in your equipment. So if some wire with power on it winds up touching the chassis, the ground should protect you because it'll ground the chassis, and you won't get a zap from it when you touch the chassis. You know, what should be happening is there's a ground on your chassis. It goes through the normal ground of the house into whatever ground you have for your building. And all buildings, all houses are supposed to have a good AC ground to them. It's in the building code. There's always the question, if you've got an older house, whether you really do still have a good ground. Okay. For example, I must have spent 15 years staring at the ground for my house and looking at it and thinking that it was just a ground wire for Cablevision, and it was a fairly thin wire, and it was going to a ground rod that was, it probably was at least 8 inches long, and it was in the ground sort of at a slant, right? You know, and so it wasn't more than maybe 4 inches under the ground, under surface. And I just was thinking that must be for Cablevision. One day I realized that it wasn't connected to Cablevision, it was connected to CL&P's wires. And I had an electrician come in and check. He said, no, that's your building ground, and that is so far out of code it isn't even funny, and so unsafe. So it's something you should have checked. Over years, especially if you have an older house, but even if you have a newer house, if you've done any work on the house or whatever, you may no longer have a good ground. There's supposed to be a ground at the entrance to the house. So you should have that checked. But this is the basic concept. So if there's a short in your equipment, it's going to go through, it'll go through the ground into ground and not through you. In your equipment, the black lead from your power supply into your radio is grounded. It is a zero ohms into the third prong of your outlet. So again, you've got that AC ground. So if you take if you take an ohm meter and you press it and you put one lead here, and I wouldn't stick it in there, but if you touch it to the plug, to the third prong in the plug, you should see zero ohms, or some very low ohm.
You said the black wire. The black wire is a ground, and the white one is the hot wire.
The red. Well, in our radios, they're almost always red.
Yeah. Okay. But because you got 2 wires there, but you got 3 wires down at the outlet. The third prong is the ground, is intended for ground. Yeah, but where is that hooked into? Does that hook up to the black wire coming out of the?
Yes, that's what I'm saying. If you take an ohm meter and you've got this hooked up, you hit you hit one side of your ohm meter here to the third prong on your plug, and one side to your ground log or to your chassis or whatever, you should see a low impedance, or low resistance. Andy, you looking?
Not always true. Astron power supplies. I have a couple Astrons, bad Astrons, and I've read a lot about how to fix them up. The current wisdom is that they are supposed to be isolated ground. So the black conductor is not connected to ground, it's isolated. So that you should have an infinite.
Okay, then I'll have to update this.
Yeah.
So, and that is the way it's supposed to be with the Astrons?
Well, I would think this is correct, but I've read this about Astron power supplies, and I suspect there are others as well that may be isolated. Okay. So you got to do it on a case-by-case basis.
So watch out for the isolated power supply. What that means is that thing doesn't have an AC ground. Okay. Now you say, yeah, but I only got 12 volts going into there, so big deal. But there are spots in a typical 100-watt transceiver where you've got 1,000 volts. So you could get yourself a nice zap if something is it's 1,000 volts. It may or may not be at a high current, but it's 1,000 volts. You're going to get yourself a nice kick. So you should test that. I tested my rigs. No, I don't have an Astron. That's right. I have this Samlex and I have a Jetstream. Both of those are what I'm showing here. So if something says isolated ground.
Astrons are linear power supplies. They have a big transformer.
Oh, okay. And that may be why. I'll have to update this. And the basically what I did is I hooked everything up and I tested with an ohm meter to convince myself that, yeah, it's okay.
John?
Yes?
Isn't the ground on the back of the radio grounded to the RF ground, which is...
Well, I'm going to get to that, but yes, the ground at the back of the radio is connected to the outside shield, and it's also, if you have this situation, it's also connected in here, and it's also connected to the chassis. So if you ground your radio through the lug, which is intended for RF, you'll also be getting AC ground. So, and remember that, well, what the design is supposed to be is that the outer ring, the shield of the conductor of the coax, that side is grounded. And it goes to the ground lug, and it goes to the chassis, and it goes everywhere else. If it's working, if it's connected. If you've got an older radio, who knows? If you've got a newer radio but something broke. So it doesn't hurt to take an ohm meter every now and then and check and make sure everything in fact is still working correctly. Okay, well, what about older equipment without the third prong? I don't know if anybody here is operating that stuff. Older buildings with two-prong outlets. Bad wiring. You know, somebody did some work on the wiring in your house, and in fact, the third connector isn't really going to ground. They forgot to connect it. They connected it wrong. You can have things reversed so that one of the prongs that's supposed to be power is ground, and one of the prongs that's supposed to be ground is power. People have made mistakes, especially if they've done their own wiring. People make mistakes. You may not have a good ground for the house, like I didn't have. There are various devices that are sold. They're called outlet testers, things like that. They range anywhere from $7 to about $400. I cannot figure out what the differences are when I look at the catalogs. But basically, you stick it in the outlet, and it'll tell you whether you've got a ground or not. I think what it's telling you is if you're going to the ground, the central ground of the house, but it's not telling you if the central ground of the house is a good ground. For that, you really need an electrician.
I think you can measure up the grounding.
There are devices that will measure it. The question is whether you know how to use it properly or not. It's not just a simple matter of plugging it in and going and pressing a button. The recommendation is if you've got any question about the ground, whether your house has a good ground or not, get an electrician to take a look at it. Don't go buying your own equipment. It requires some specialized skill. But at least at the first step, check your outlets. Okay, especially again in an older house, some of those outlets may not be wired correctly. They were probably retrofitted. Somebody may have just retrofitted a three-prong outlet without actually connecting the ground. You know, I used to have a two-prong outlet. My house had two-prong outlets. I got all these devices with three prongs, so I just substituted three-prong outlets for two-prong outlets, but I never actually ran the wires necessary to make that work. So check it. You may or may not have a ground.
Usually it's taken care of because of the older houses. They use BX, and when you screw it in, but what people do is they reverse the hot and neutral wires. And then maybe I don't know if everybody knows the difference between neutral and ground.
Can you give us 5 seconds?
Basically, the neutral and ground do get tied together at the box. That's the only place they're supposed to be tied together. And they're different. If you're in a farm, you have a little different rules than you have on a house. But anyhow, just always remember the blades. The big blade is the neutral. The little blade is the hot wire.
And the third prong is supposed to be, and
The
round wire is supposed to be
the ground
the
wire,
ground.
which what you have is screwed to a metal box, but of course, a lot of stuff is non-metallic.
Which is green.
Right.
Yeah, so you
Because
have,
Inside the box, it would
I'm
be
not sure,
a...
how they're doing, here, but in Poland, I know, like, when they're doing the grounding on the house, on any building, before the grounding is attached, they are measuring the impedance of it to see if the grounding, it's enough grounding, so it's like enough, rods and all the,
Right.
things, run. So they doing this and they measure up if there is enough, grounding.
There are all sorts of requirements in the building code, but if you have a house that you've been living in for 20 years there, and you bought it from somebody, who'd been living in it for 20 years beforehand, there's no guarantee that that stuff is still working.
Or it's not rusted or
Right.
it's gone.
Right. And you never know, somebody may have screwed up when they were building the house. So it's worthwhile getting an electrician to test, to check it. Okay, so that was the basic AC grounding. RF grounding, the goal is to dispose of the RF that's getting into the shack. RF can get into the shack two ways. One way is coming down the feed line. The other way is the stuff in the shack, the wires, whatever, pick up RF, especially if your antenna is near the shack. Okay. So the basic concept is you've got the shielding of your coax is grounded. It's grounded in the radio. Again, most radios do that. On an older radio, can't guarantee that it is. But that's the way all the modern radios are built. So that goes to ground. It goes to, there's a lug in the back. There's a grounding lug in the back. So that will help eliminate any RF that's coming down the line. Even some of the equipment and cables in the shack that can deal with some of it. You all know about putting chokes and ferrite beads and on your wires in the shacks to further prevent RF from being picked up. Andrew, you look like you're questioning. No? Okay. However, well, first of all, let me go back to this. The ground that goes through your house, now think about it, if your radio is working properly, and aside from that Astron question, the coax shield is grounded to the same ground that's the chassis, which is the same ground that goes through the black wire, which is the same ground that goes through your power supply, which is the same ground that goes through the third prong of your plug, which is the same thing that goes to the house ground. So doesn't that mean that you have a good RF ground? And the answer is no, because all that wiring in your house to RF looks like a high impedance typically. You've got coils and you've got stuff running every which way. It typically looks like a high impedance, so the RF is not going to go down that path. In fact, what it may do is just start setting up some loops inside your radios, things like that.
Every once in a while, you may notice when you're operating mobile particularly, you put the radio on, you put your black and your red wires, you attach them and everything is fine, turn the radio on, it doesn't work. You plug in the antenna and all of a sudden the radio comes alive. You know what that means? You've got a bad ground. Whether the fuse is blown on the ground side or it's not making contact or whatever. But you're now grounding through your antenna, which is not a good ground for the vehicle.
Okay. So, what we want to do is use grounding strap with a very short run outside to a good ground. A nice 8-foot ground rod, buried straight, vertically, not stuck sideways into the ground. And we'll talk about that a little bit more. And there's a lug. This is the back of a 756. There's a ground lug. There's typically a ground lug in every piece of equipment. If possible, you want to use this ground strap because it has a very low resistance to RF. very low impedance to RF. And one of the rules is you don't want to daisy chain directly from pieces of equipment to a piece of equipment. You want to have one piece of ground strap and connect to the ground strap coming out. And the main reason is so if you have a problem, you won't lose the ground for everything. You know, if you just put a serial connection from here to here to here, if anything goes wrong here, you suddenly have lost your ground. Plus, being that it's near the equipment, it's going to feed RF into the equipment. So you want to get this away from the equipment, let it run over there, right out to outside as quickly as you can. You know, as directly as you can. You want a very short run, and the reason for wanting a short run is that if you have a long run, it becomes an antenna, and it starts radiating. So the RF that you're trying to get rid of is now radiating right near your equipment back into the house.
Just want to say something. That also when you do the RF grounding, it's best to use the tape or the braid, wire instead of regular wire, because the RF tends to go on the surface of whatever you're going to be putting. So the wider pieces of any metal, it's going to work good.
Yeah, that's why the ground strap, because it's essentially all the outer. It's all outer, and there's a lot of it, so it's a very low impedance, very low resistance, very low impedance. So you're going to get your RF going right out into that ground. And depending on where you are, our soil here is not great, but it's not terrible. If you're in a place where it's all sand and whatever, you may wind up putting multiple ground rods. You may wind up watering the area every day. There are kits now for people who live in a very rocky, a very sandy area, where it's basically a tube, and you fill the tube with water, and it's got little holes in it, so the water slowly seeps out. You put your ground rod in that. That way, you've got your ground rod into a moist area that will disperse the RF.
I'm going back to when I had a station years ago. Back then, when I did the grounding, I had made one central grounding connection coming into the shack, but I tied it into the water line, I tied it into the radiator pipes, and in addition to an outside ground. Generally
you're okay tying into the cold water pipes, not the radiator, because the radiator pipes go to the furnace.
Yeah.
So by the time all is said and done, there's no real route for it to get to ground. And if you're feeding it back through the furnace, you can get what's called a ground loop. And we'll have a little bit about ground loops later, but a ground loop is a situation where we have multiple grounds, but they're not all at the same potential.
Okay.
And when the grounds are not all at the same potential, you wind up getting a current between them, which defeats the whole purpose, especially because when they're not at the same potential, usually that current will wind up traveling back up through your equipment to the other ground.
What about counterpoises
What about them?
as RF grounds? Because the thing is, I live in a third floor apartment.
Right.
Everything below me is hell. The house was built during World War I. And to get a decent RF ground, I would have to use two counterpoints. And I thought of just a tail made up of individual resonant wires hanging out the window and down the fire escape.
This is something different.
A wooden fire escape.
Yeah.
How do these?
Now,
how does this work in light of what you said?
The counterpoise is to balance off the antenna, so you have a balanced antenna. And if you have a properly balanced antenna, you're less likely to get RF back to the shack.
The counterpoise is used as a ground. It can be used as a ground, an RF ground. MFJ sells an RF ground,
Right.
which is basically a tuner for a counterpoise.
Yeah. The thing is,
Okay.
I also had the idea of making a counterpoise tail that I could roll up and spread out for portable operation. So I just wanted to get some ideas about how this performs.
I don't know.
This
Andy?
is, but the counterpoise, that's pretty much, when you put any wire as a counterpoise, that's gonna be the wire, that's gonna be the ground your antenna gonna work against. So this is, usually it's very tough to ground, a shack, if it's like, a few stories, above the ground. It's really a challenge, and I read, a lot about the people, having a problem, because the best thing is just when you're on the ground, level, and the shortest run, to the soil, to the actual.
Now, when they say it's an artificial ground, is it really an artificial ground for this, or is it an artificial other side to the antenna?
It tunes the ground side of the antenna.
It tunes the ground side of the antenna. So, which you need, but again, what that results in is something that is basically, effectively, it's a balanced antenna. If you have a balanced antenna, you're not going to get, properly balanced antenna, you're not going to get RF back into the shack.
Basically, like if you're using a long wire,
Yeah.
you would use this for the counterpoise, and you tune it to the frequency.
Yeah. So
It works
normally,
really well.
normally with a long wire, here's your rig, you got the long wire going out, and then you've got something that's supposed to go to ground. If that can't go to ground, the artificial ground with a counterpoise will look like the other side of the antenna and wind up creating the balanced load. Because remember, most of the RF that comes back in the shack is coming back because you have a mismatch. You don't have a balanced antenna. You have some sort of an SWR there that's causing RF to come back in the shack. There are other reasons for RF to come back in the shack that this may not deal with. For example, if you have a long run of coax that is parallel to your antenna, you can get that coax can pick up the signal and act like an antenna. That's why, for example, with twin lead is especially subject to that. So when you have twin lead, you always want it coming perpendicular out from the antenna and going a considerable distance away from the antenna before you, if you have to turn it so it runs parallel to the antenna. In fact, what you're better off doing in that case is putting a balun out there, bringing the twin lead to the balun, and then having coax that you run along the ground or bury, if you have to have your coax running parallel to the antenna.
Also, when the antenna is close to the house, your electrical or any wires might act as the antenna on the house. That's why most of the wires are just split, together to, I don't know how to explain, but the wiring, they're not, straight up, but they just, all, twist. Yes.
Yeah. That's why they twist.
Yes.
They twist the wires a lot to prevent it from picking up the RF.
Yes, the RF.
And then what you want to do is you want to have chokes on everything. I mean, everywhere. Especially if you're running digital, because coming from the computer can pick it up. You want to put chokes on the computer can be very sensitive to that situation. If you're running digital, your PC can be a real problem and a bad source of RF coming back. So the answer is, what you're talking about is supposed to eliminate the RF that's coming back through the shield, because it prevents RF from being generated on the shield. It doesn't necessarily deal with RF that takes place because of your rig itself or your wiring. That's not going to help with that, or not help very much. Oops. Trying to break that. Okay, so second floor or above, one of the things that's been suggested, I've already said this, that if you've got a long run, the impedance may be high enough on your long run that the RF isn't going to go to ground. it's going to flow through your radio, or the ground system itself, if you're up high, may be long enough to actually be a radiator. I don't know if you guys know the wireman. He's a source of wire. He's got a solution that's worked fairly well for me. He says you take any length of RG8, up near the shack you put a 0.01 microfarad capacitor across it, you short another one down here, and you run that as your ground. And he says it's effective. I know it worked for me when I had my rig up on the second floor. And I got rid of a lot of RF that way. So you have this, and then this right here is going to be attached to the ground lug. And the center conductor down here is going to be attached to the to your ground rod. So that's one.
The shield is not touching the center conductor, just the...
The shield is not touching the center conductor, but it is, they are connected via the two capacitors.
What was the voltage rating on the caps again?
1,000 volt DC. That's what he recommends. Now, like I said, it worked. It worked well for me on a 100 watt, standard 100 watt rig.
Does it have to be hung vertically, or?
I don't know. He doesn't say anything about that, whether it needs to be hung vertically. Again, you should make it as short as possible, but to the ground rod. But I don't know. Now, Radio Works, the guy who does the antennas that Terry used to like, the Carolina Wyndhams, he recommends what he calls a grounded line isolator. Basically, it's a balun or a choke with a ground strap. So you take the ground strap, and supposedly it's designed to pass the RF on the shield to the ground. I don't know. He sells a lot of them, so I don't know, but it's another possibility. A couple of other things to do to minimize RF back in the shack. Of course, antenna location is one of the primary things. Now, we may not have a choice, but if your antenna has got to be near your shack, you're going to have more issues, especially if you're in the near field of the antenna. You want to keep your feed lines not parallel to the antenna, as much as possible perpendicular to the antenna. If you can't do that, you should very much consider burying your feed line. Either buy bury flex or run it through some PVC pipe and run it, and then put a big mother choke where it comes into the shack. I got a big homemade choke that I've got that's been very effective. Open window line, ladder line, any of that kind of open line coming into the shack is almost always going to be a problem, especially if your rig is not sitting right there by the window or right there by where it's coming in. So my brother at one point he had his rig, let's say in this corner of the shack. The ladder line came through here, then curved, then there, came in that window, back this way to the rig, and he had horrible problems. And he couldn't understand what the problem was. And Erwin, you've got your antenna sitting there radiating, right there in the shack, right next to the radio. And I finally convinced him to put a balun out here and run coax through the wall, and magically all of his problems went away. But that's open wire, open line is a problem. Long wire, same problem. Long wire, what you really want in long wire or ladder line is you want that stuff to go right out the back, perpendicular to the radio, and right out to a faraway antenna. If you start having it snaking around the shack or snaking around in the shack or anything like that, you're going to have some serious RF feedback problems. Obviously, short wire runs in the shack and ferrite beads on everything and anything in sight. I keep trying to glue them onto Tina and she doesn't like it, but what can I do? Okay, ground loops. In imperfect soil, different grounds may not be the same. So if you've got a ground, let's say for example, the house ground is in the front of my house, near the front of my house. My shack is near the back of the house. So if I have a ground here and a ground here, I can very easily have different voltages or voltage difference across these two. And once you have a voltage difference, what's going to happen? Current's going to flow. Where's the current going to flow? Well, in Connecticut, fairly rocky soil. That's fairly high resistance. Back through the rig, fairly low resistance. Guess what? Okay, and that's a ground loop. So, in fact, the code generally specifies that all your grounds should be tied together with low resistance, low impedance wiring to keep them at a constant potential. And you shouldn't really have separate grounds or separate ground rods. You should have one really good massive ground and everything tied to that. And that way you avoid the whole concept of the ground loop. And the ground loop can really kill you in cases of lightning, because then we're not talking about, a couple of volts differential. We're talking about a bazillion, gazillion volts of differential, which means, approximately, which means a lot of voltage going back through your equipment and flowing. And remember, this ground is flowing through your house, which means it's flowing through lots of other things in your house, and you can blow everything. So, we'll talk about that more in a minute. This is a guy, W8JI. He has a website. He's got some very good information about grounding. I recommend you look at his site. But what he's done here is he's taken the grounding strap, he's connected it to the ground of the third prong, if you will. He's connected it to that ground. That ground strap goes up to his radio and then goes out to his ground. So he's tied all his grounds together.
To an outside ground rod.
Right, to the outside ground rod. And that way he's got everything on low impedance line, so his grounds are essentially tied together. So he's to try to prevent these ground loops. Anyway, W8JI, he's got a very nice website with a lot of good information. I recommend you read it. But this, that one surprised me, but that's what he's doing there. All right, so lightning. All right, I was wrong. Lightning is a million, trillion, bazillion gigavolts. We all know it's huge amounts of voltage. It's got a very fast rise time. A very fast rise time means, quite literally, that you can have, if you have a ground here and a ground there, you can have some serious voltage differential between those two grounds. And you're going to get a serious current flowing through those two grounds, and chances are that current's going to wind up flowing through your electrical equipment and blow everything all to hell. So what they do in places that have serious problems with lightning, like Florida, you'll see patterns like this. You'll see multiple ground rods in a fairly contained area. Multiple 8-foot ground rods to disperse it, and that's it. Everything is grounded to that point. But everything in the house ground, the radio ground, all the ground is tied into one ground system, so that there is no voltage differential between the different points. When you look at something like Sterling Farms, every piece of equipment is tied into the same ground. They have this huge monster grounding cable, and every piece of equipment has to be tied to that grounding cable, and that grounding cable goes out into this monster farm of ground rods. Cold water pipes are okay, because cold water pipes eventually go right back into the street.
As long as they're all copper. Now they.
Well, yes, right. If they're PVC, that doesn't help you. If they're all copper, hot water, no good, because it's going to go through your furnace.
Yeah.
And chances are it's not going to go to ground.
Cold water, you have to worry about if you've got a well or pump.
Yeah.
With plastic piping.
Yes. Well, that's what it said. Yes. cold water can be okay if what you've got is city sewer, is city water, and you know that it's all copper.
Plastic meters. Some of the meters, there's too much plastic, so depending on what side of it you ground.
That's true too,
may or may
yeah,
not
okay.
be grounded, the piece going
So
outside.
the answer is the cold water may not really work very well.
Well, if you tie it in below before it gets to the meter, you're okay. Usually you do
If
have
you do,
access.
yeah.
You have to pay attention to where.
But mostly when people are doing that, what they're doing is they're going into the bathroom and tying into the cold water pipe.
Yeah.
And then you may not have a good ground. In older houses, that wasn't a problem. That wasn't an issue. In a lot of newer stuff, the cold water pipe isn't going to be good enough. What? Yes, no, or you
I was just
agree?
going to say, in my house, I have copper piping with a ground clamp on piping inside the house, going to the service panel and then out to the ground rods.
Okay.
So there is a continuous path from all the copper throughout the house to directly to the ground,
Okay.
but not in every house.
Yeah, not in every house. And again, the house may have been built just fine 20 years ago or 40 years ago. In the case of my house, 80-something years ago. But the house, has been worked on so many times, and things have been redone. The electrical distribution was redone. Apparently, before I bought the house, I know they had done some major rework of the electricity, and whoever came out and did it just said, yeah, I'll just hammer a short piece of wire short piece of ground rod into the ground. I'll call that the ground. And I guess when that was done, which was probably about 35 years ago, nobody looked at it. Because it probably didn't meet code back then. It certainly doesn't meet code now. So keep that in mind. Look, lightning, if the lightning hits your house directly, chances are, like if you've got a 2-meter vertical on your house and lightning hits directly onto that 2-meter vertical, even if you have a ground cable from that antenna, chances are just the heat alone is going to do serious damage to your house. But statistically, lightning most often hits utility poles. Why? Because there's so much wire there. It's a nice big fat target in effect. Whereas your house is just this little tiny target. That doesn't mean your house won't get hit, but usually it's going to hit lightning poles. If there's a tall tower or a tall vertical nearby, well then, the lightning does like to go for the highest thing. The towers are the poles are supposed to have a ground on them. They're supposed to have ground protection on them. If you walk around Stamford and you look at most of the poles, you'll find that at least half of them have broken wires where the ground wire is. They're just, they broke off years ago. Nobody's fixed them. Interestingly, if you have separate ground for your ham equipment that isn't tied to the ground coming into the house, you actually increase the likelihood of lightning striking that, because as the voltages build up, lightning doesn't just happen. Some voltages start building up, and as that builds up, you have a ground loop happening, and lightning looks at that and sees some current flowing and says, oh, good, I'm just going to join the party. So statistically, if you have separate grounds, you have a higher chance of damage, of getting hit by lightning. Also, yeah, newer poles have some ground fault equipment, so they route all of the power from the lightning, or all of the current from the lightning, they route it away from the pole down the line. Guess where it's going? Into your house. So that's a problem. When you have different entry points, this is saying the same thing over again. When you have different entry points, there's different voltage possibilities. So look at the typical entry points. You've got your power entry point. You've got an AC unit sitting out here. You have a satellite out here. You got, you might have, here, CAT, and is an older drawing, of course, cable and phone. All right. Each of these is a different entry point, and each, as the lightning is building up, each can have a different voltage on it. With the result that you're going to have current flowing through the house, even if the lightning doesn't strike you directly, you get the strike over here to a nearby object, there's going to be all sorts of different voltages on these different pieces, and they're going to cause current to flow through all of your equipment. So again, if you have everything grounded to one ground point, you're going to be safer because all of that's going to get bled off. There won't be the different voltages. But once you have separate anythings, you have the good probability of different voltages and the ground loops. Stan, did you?
I said, good luck.
Yeah. Good luck, right. So, this is what this guy has, this W8JI. This is what he has. It's kind of a mess to look at. Can you see it? Everything coming into his house comes in through one common entry point. He's got it all wired, one common entry point. This is basically a big common ground. The shields on everything tied to this common ground, and then you can't see it in here, but then there's the strap that goes out to his grounding system. So everything coming into his house goes to one common grounding point. All of his antennas, his cable, his control cables for his beam or beams, his cable, I said that, his phone, everything all comes in through that one point. And it looks like a god-awful mess, but everything is tied together. The shields are all grounded. They're all grounded closely in one spot, so there's effectively no resistance. Right there into the ground, there's effectively no resistance. He's not going to get ground loops. And when you look, again, you go down to Florida and you look at what there are companies that will protect your house. It's the same kind of companies, same kind of work that's done on things like Sterling Farms, the city's equipment there. The key is getting everything to the same ground point, and then a big farm of ground rods. And then if necessary, water, keeping that area moist so it's got good flow, it will dissipate the current quickly.
John?
Yeah.
I've heard of chemicals being used in conjunction with that water flow. I think it was Epsom salts, that you can saturate the ground with that. Is there anything else?
I don't know. I can check, but I don't know.
And wouldn't the environmentalists have a fit about that?
I don't know. I don't know if it matters for that small an area, but I just don't know.
Are those just barrels for ground connectors, or are they the units that will blow when lightning hits?
These here are just the barrels.
Okay.
Things like the lightning arresters would be outside. Well, actually, they would be close, but there are none of them in. As far as I know, there are none of them in this picture.
Okay.
And again, they should be close because you want them tied to that same ground. Otherwise, you're going to wind up with ground loops. So, denying lightning to come through the antenna system. The first and best thing is, when you're not using your rig, disconnect the feed line and throw it outside the house. If it's thrown out, if it terminates outside the house, it's not going to come in the house. That's really the best thing, and that's what people do a lot of people do down in Florida. Other places that have lots of lightning.
Do it around here when you get a lot of thunderstorm coming.
Yeah, I mean, I always disconnect and throw the stuff off. In the summer, basically, my coax is sitting outside the house unless I decide I'm going to get on the air, and then I pull it in and connect it up. Probably being a little paranoid, but okay. A lot of antenna switches will provide a direct line to ground. So you might have, let's say, 4 positions plus a 5th position, which is ground, and what happens is it connects the incoming antenna lines to ground and goes back outside. The one problem with that is you're still letting the lightning come into the house. In theory, it's just going to come into the house, flow through your antenna switch, and flow back outside, but do you really want it in the house?
Yeah, it can easily jump over to anything.
And are you sure that's not going to arc? Are you sure that's not just going to fry that antenna switch and, poof? But that's one way of doing it. The best way really is take your coax, get it outside the house. And by the way, don't just throw it out the window, because you can get a nice super duper arc when that, billion gazillion volts comes down to the end of that cable, and it'll flow through the ground. Or if it's near the house, it'll set the bushes on fire. So great, I didn't get it into the shack, and I didn't damage my $1,200 radio, but I set the bushes on fire, which in turn set the house on fire, and I lost the $300,000 house. So ground it. What I have in my house is, I'm not saying it's the best, I'm just saying, what I do is I've got my house, I've got a driveway, and then I actually throw the line out over here, and I have it connected up to a ground rod when I'm not using it. When I remember to do it. Sometimes I get lazy. In the summer, I'm good about it. In the winter, not so much. DX Engineering, for example, sells a unit. I couldn't get a very good picture of it, but basically, it's a unit that you connect everything through to this unit. It grounds it right here, and then you can just disconnect things if you want. So everything is always into a nice ground. The typical lightning arrestor looks something like this. You've got the coax coming into the lightning arrestor. You have your coax going to the shack, and then there's a connector here for the ground wire. And there's something in here, a tube of gas that normally is a very high impedance, so that nothing is flowing through to the ground. But then, if there's a high enough voltage, that voltage breaks down the gas, and you get a zero impedance down into the ground. People debate whether these things are useful or not. For example, remember, lightning has a very high rise time, so it's very possible that the voltage could get very high very quickly before that gas breaks down. So for that first millisecond, you get a couple of hundred amps flowing through your equipment. Then it stops, but unfortunately, it's too late. People debate about it. It's better than nothing, but the real answer, one of the real answers is, don't have this coming into the house when there's lightning. Even those window units like MFJ has, don't let it come to the window unit. Get those things disconnected outside, and get the cables thrown away from the house. Like I said, if you take a direct hit to the house because you got a 2-meter vertical sitting up at the top of the house, or you got a beam sitting up at the top of the house, chances are you're going to have damage. You're going to have serious damage. One could say it almost doesn't matter, but it always matters to try to minimize the damage. Because when you get hit, when that chimney gets hit by lightning, the chimney's going to take just the amount of heat that's being dissipated is going to set your roof on fire, if nothing else. If not blow a hole in it, so. And that's it. Ground everything, common ground. Make sure your grounds are working. Make sure the wiring in your house is good. This is a good time to do it because it's not the summer when you're really going to be worried about this kind of stuff. Get the ground strap, get your ground set up. It will improve the performance of your radio. If you're on a second floor, try that wireman thing. He's got a little kit. It's just the 2 capacitors. Try that little kit. It worked for me. It should work from the 3rd floor if you can do it. Any questions? Andy?
One thing that always confused me is all the instructions say ground at a single point, yet the power connector of your grid, as you demonstrated, is connected through the electrical ground system to the service panel, which may have its own, should have its own ground rod. Is the one point you're grounding to, does that share those ground rods, or is it different?
It can be. What they do, what that guy does is he's got everything flowing back to those ground rods.
Like it's whole house service panel and grade.
Yes, go to that ground rod. You may wind up with a field of ground rods, but they will all be strapped together so that there is no voltage differential between those ground rods. You know, strapped together independently of the service panel is what he's saying. So that you're not counting on the current flowing through your house, through all the wires in your house to get to the ground rod. You're taking that lug, you're going right outside the house, and then strap, and then that goes with a, with a braid to that central common ground point. Now, what they do in Florida sometimes is they will have multiple ground rods, multiple pools of ground rods, but they will have a very heavy, sorry, not heavy so much as very big flat cable going between those multiple pools so that there isn't a voltage differential.
And a lot of times there is like a copper tape
Yeah,
connected. And even the house, it's all looped, like, I don't know how they doing, here, we never, saw it, but I was working a little bit, when I was back in my country. So sometimes there are like, the house has 4, corners, so you have the ground rods on each corner, and everything is all looped, with the,
tied together.
everything is tied together.
Yeah, and that's one of the key is tied together.
And then you measuring the impedance, and impedance, it has to be the lowest as possible. It gotta be some certain impedance before this is actually attached. If there is not enough, that means, you're gonna have to put another rods, to get that balance, closer to zero.
Now up here, typically the builders will put in a 22 gauge wire or something.